answering this biochemistry question here. So there we go. So right here we have some definitions and some equations given to us. And then we look here, E, molar absorption coefficient, typically called the extinction coefficient. It's how well something absorbs in a certain frequency of light, or wavelength in this case of light. I, or L in this case right here, is going to be the path length in centimeters. It's a standard number. Typically it's 1 centimeter. And then C would be your concentration. A would be your absorbance. It also gives you the absorbance equation, which is absorbance equals the log base 10 of your intensity of your light with nothing there, divided by the intensity with what you have. So how much it could possibly absorb, divided by how much it is absorbing, essentially. And so the first thing you have to do here is you have your 1 milligram per milliliter myoglobin solution. The molecular weight of it is this number right here. Notice this has units of molarity. So given that the extinction coefficient of myoglobin is this, again, look at the units of molarity, calculate the absorbance of myoglobin solution across a 1 centimeter pathway. Okay, so we're going to be using this equation here. This right there is that number. The C has to be in molarity because it says molarity right there. So this will need to cancel out. So you're going to have to convert this number right here to molarity. Plug that into the equation, multiply it by this number, and then multiply it by 1. To do the conversion to molarity, you use the molecular weight. A kilodalton is 1,000 grams per mole, essentially. So you have here 16.8 kilodalton, kilo 1,000, right? And so, did I just say 16.8? 17.8 kilodalton. And that would give you 17,800 grams per mole. Man, this thing is annoying. Okay. And so you had a milligram per milliliter. You need to go and do a 1,000 divided by 1,000. So that doesn't really change. So you can actually change that then to a gram per liter. Notice they're milli, so those cancel. So you're being left in 1 gram per liter. So that means that you then need to convert this number of grams that you had, 1 gram per liter, into a number of moles. You do that by taking the 1 gram and dividing it by the 17,800 grams per mole. That'll give you this number right here, 5.617977 times 10 to the negative 5 molarity, or moles over liters. Okay, so now that you have your molar concentration, your moles per liter, or molarity, you can take that number, multiply it by the 15,000 that was given you for the extinction coefficient, and times 1 for the 1 centimeter. That will cancel the units out on this, leaving you in a unitless number, which is your absorbance. All right, so once you have your absorbance, which is 0.84 is the number you'd want to put in, because this is 2 sig figs right here. You're going to then need to do the second part of the problem. Now, the second part of the problem is what percentage of the incident light is transmitted by this solution. You'll need to calculate this to 1 decimal place. It's actually nice that they give you this 1 decimal place, otherwise it would take some work to figure out exactly how many decimal places you should actually get due to the fact it's a log. That's going to be in between these. Okay, so we have absorbance, 0.84. You'd want to go ahead and use the full number, by the way, when you do the math. That way you don't get any rounding errors. So you put in that 0.84 number right here. This right here is going to be intensity. Now we have the intensity of the clear solution, nothing in it, divided by the intensity of the solution that you're going to be using. So what I'd recommend is just putting your absorbance in here, solving for these values right here. I0 over I. How do you do that? Well, you take 10 to the power of. So you'll take 10 to the power of 0.84, 10 to the power of log to the 10 base, 10, will cancel out, leaving you with 10 to the 0.84 power equals I0 over I. The next thing you need to do is you don't want I0 over I. That's what I was just saying right there. That's what you end up with when you solve, get rid of that log. So if you go ahead and put that in your calculator, you're going to get 6.92 or 6.962407, whatever. And that is almost the opposite of a percent transmittance, okay? Because a percent transmittance would be the amount of light that goes through. This is the amount of light that's blocked, actually. That's why it was used to get an absorbance, right? How much of it was absorbed, not how much of it is transmitted. And so what you need to do is you need to take this number and you need to use it to get the inverse. And so to do the inverse, to flip these numbers upside down, you'll take 1 and divide it by the number. So you're going to take 1 divided by 6.962, like so. And that will equal the amount of light that passes through divided by the total amount of light that could have passed through. This will give you a number that's 0.143649, or you could round it to 0.144. And that needs to be multiplied by 100% because right now it's a fraction, right? Multiplying it by 100% will give you 14.4%. You need 1 decimal place, so you rounded it to 0.4. There you go. Please let me know if you have any problems with this, you don't understand anything. I went ahead and covered everything for posterity purposes because honestly speaking, a lot of times these videos get watched by other people later or sometimes during. You take care, have a good day, and let me know if you have any other